In this tutorial, we will see how to plot Climograph using ggplot2. Climograph is basically graphical representation of basic climatic parameters like temperature and rainfall. These are basically averages taken over long period of time, say 20 years or 50 years. First, we will download the dataset. So link to the dataset is given in the description of the video. Alternatively, you can also Google for climatology of important cities. So we have some information regarding data on the left side. So there is information. This data is provided by Indian Meteorological Department. We will download Excel file. So I already have downloaded the file, so I will not download it again. You need to specify name and email address over here. I already have the data file. So we have this information. We have mean temperature in degrees Celsius and minimum mean temperature for degree Celsius. This is maximum and this is minimum. Then we have rainfall in millimeter. So first there is some problem with the file. So first we need to save this file with another name, or we can save this file as it is. So now let's load the data. First we need to import required packages. Let's load the packages. We'll require then plier, dplier, and ggplot2 and reshape. So now we have the data in the environment. So let's move ahead. If you observe, not all the stations have 100 years of averages. For some stations it's 43, then there are some stations with 34, and it's all mixed. So we will focus on only those stations for which we have uh, maximum minimum temperature and rainfall for 100 years of average. First we'll see the number of stations. So there are total 111 stations. We will select only those for which we have 100 years of average data. So we have this new data frame. Now let's see how many stations there are in this. So there are total 17, 18, 19 and 20 stations with 100 years of average. Before we move ahead to create a climograph, we will change the column names for the data frame. So since there are some names are very long, like this temperature for temperature and even for rainfall, I prefer names with without symbols. So let's rename the column names. We'll rename maximum temperature as Tmax, minimum temperature as Tmin, and rainfall as rainfall. So now we have column names changed. Now let's plot. We can create a really good climograph using ggplot2. On x-axis we'll plot months, then on we'll use geom bar for rainfall. So y-axis would be rainfall. Since there are number of stations, actually 20 stations, so we will create separate facet for each station. So for that we will use facet wrap, and we'll specify that for each station we want different facet. Via static we need to specify stat as identity. Since we directly want to create bars of specified length which depends upon the value, and we are not interested in creating frequency or frequency count or histogram. So here we have our first output of climograph. We need to make some changes to make it more correct. We will make this, we will have to change the orientation of x-axis names. So let's do that first. So we'll create theme, axis text x, element text, angle as 45, vertical justification 0.5. So here we have months. These months are arranged according to alphabetical order. Since R does not really understand the order in which month should be presented, so we need to correct this. We need to arrange them from January to December. So let's do that. We need to rearrange factor levels for month column. Here we will specify each month in order. October, November and December. So now this should be data 100. So now we'll recreate the plot. So here we have all the months from Jan to December, and accordingly if you observe in monsoon, that is June, July, August, September, the highest rainfall is observed as it should be. Let's move ahead and plot temperature also along with rainfall. For temperature we will use line. First we will have Tmax, then Tmin. We need to plot both minimum and maximum temperature. We need to specify a group aesthetic. So here we have temperature also. Since for both rainfall and temperature this scale is used, which goes from 0 to 600, and because we have rainfall up to 600 mm, but temperature will hardly go above 50 degrees Celsius. So we need to create separate axis for temperature and another one for rainfall. So let's move ahead and create secondary axis. Sec axis. Let's rename this axis as rainfall in millimeter. Since we are going to create this secondary axis uh, which is 10 times the original axis, this one, we also need to divide rainfall values by 10 over here. So now we have secondary axis for rainfall which goes from 0 to 600, and this one we will use for temperature which goes from 0 to 60. So this one, this axis is 10 times more than this. We'll add labels to the plot. So x as months, then y, this primary y-axis as temperature in degrees Celsius. We can also add color to the lines. Say call 10 max and size as 1. Similarly for minimum temperature. For rainfall as well, we can have color. So we have new plot over here. We can make it better. We'll use alpha for bars to make it transparent, and we can also add geo point for line just to make uh, the graph more look better. Then we can specify scale color. So scale color manually values will be given as dark green for rainfall, then red for maximum temperature and blue for minimum temperature. So now we have this new plot. We can set fill value for these bars. We can set it as dark green as well. We'll add title as Climograph. (1901 to 2000). We need to remove this color and specify it as parameter. So for that we will rename the color as parameter. So here our Climograph is complete. We can save this. If you observe, the Y scale for each facet is fixed. So because rainfall in this first facet goes up to 600 mm, all the facets have Y scale as up to 600 mm or 600. Over here lot of space is unutilized, so we can set y scale as free to make maximum to utilize all the space. Free y. So now we have different scales for each facet. So this one here goes up to 300, for this one it goes up to 600, and so on. So this looks much better than the previous plot. Of course, for comparison purpose, the first plot is better. We will save this plot as well. You can also specify your interest of stations using filter. So filter station in this vector. So say we are interested in Pune and Agra. So that climograph for only those two stations will be created. Say we are also interested in Abu and Ajmer. So likewise we can create climograph of our choice for the required stations. So this is up to creation of climograph, but using this data we can find out other details as well. Say if we want to find out rainfall according to season, or we can also find out the months with minimum and maximum months with minimum and maximum temperature for each station. So we can do that. So let's start with rainfall. So first we'll classify each month according to their season. So we'll create column as season with NA values, and then we will assign season to each month. So the month which fall in this vector, say we know that June, July, August and September are monsoon months, so we will add monsoon season for these months. So for all the stations, months with June, July, August and September have monsoon. Similarly, we can classify other months also. Suppose for after monsoon we have October and November as post monsoon. So we will specify season as post monsoon. Then we have December, January and February as winter. So December, January and February as winter. Then we have March, April, May as summer. We can also specify this as pre-monsoon, but summer is fine. So now we have all the months classified. Now we will find total rainfall for each season. For that purpose we will use plier package function, which is dt_ply. So basically we will pass all the data frame and variables would be station name and season. Since for each season we want to for each station we want total of rainfall according to season. So rainfall sum of x rainfall in a RM as true. You might want to look at examples of dt_ply function in other tutorials. It might help. We will store output in another data frame, say rainfall. So we have rainfall in this data frame. We can create plot of this using ggplot2. On x-axis we will have season, on y-axis we will have rainfall. And for each station we will create different facet. Stat as identity. So here we have plot. So for all the stations, maximum rainfall is received in monsoon, then post monsoon, summer and winter. We will reshape this data frame. So all the seasons will appear as column names and rainfall would be for each station. There would each station and each month, each season rainfall value would be specified. We'll create rainfall 2 data frame and we'll use dcast function from Reshape package. So dcast is basically used to convert long form data into wide form. So we have another data frame over here. All the column names are season So for each season, at the interaction of station name, we have amount of rainfall, total rainfall for that particular season and station. We can go ahead and calculate total rainfall, which is summation of rainfall for all these seasons. So now we have total rainfall as well. Actually, we made a mistake over here. So now we have total rainfall as well. Further, we can calculate for which which station or for each station which month had minimum and maximum temperature. First we'll find minimum First we'll find mean of temperature for each station. So T mean as mean of T max and T mean. For each station we have T mean. Here again we will use ddply function. We'll plot variable station name and function. So we need to find T minimum from T mean, then T max from T mean. Then for T mean and T max we need to find out the month in which the minimum and maximum temperature was found. Let's execute this. So now we have, actually this is not the expected output. We need to create data frame as well. So now we have minimum temperature and the month in which minimum temperature was detected, and similarly maximum temperature and month. So using this we can find out which month had frequency of the month for which minimum temperature was detected. So T mean. So we see that January is the month in which for most of the station minimum temperature was detected, followed by December and July. Similarly, we can plot for maximum temperature. So it's May. summer season. We can also try to find out the station which experiences minimum and maximum temperature. So Sn T mean is equal to so it's Mukteshwar. Then station for which maximum temperature is found. Nagpur. So let's save this dataset into an Excel file. So our original data of 100 of stations having 100 years of average. Sheet name as data. Row names false. Since row names are already present in the Excel file, we do not need row names. Then we will also save rainfall data, season wise rainfall data. Append true. Then temperature calculations. So now here we have Excel file having all the observations, original observation as well as calculated rainfall for each season and temperature. Thank you for watching this tutorial. If you find this tutorial interesting and helpful, please like the video and do not forget to subscribe to the channel.